and then I'll bring it back down here later. But it's so much easier when I have it down there, because then I can project on two screens, so I can show them how to use the program on one computer and do my PowerPoint on the other one. So there we go. All right. So what are we doing today? I don't think it's too hard. It's some graphing calculator stuff if you want to use your graphing calculator. If you don't want to use your graphing calculator, then we can go through this, because the first one I'm going to do without the graphing calculator, but I would have your graphing calculator out. All right, this one. It says graph the function, tell whether the point of discontinuity is at x equals 0. Tell whether any point of discontinuity is removable or non-removable. And you go, what are you talking about? Well, when a function is discontinuous, it has a break in it, like that. If there's a break in it, it's discontinuous. It's discontinuous. If it goes like this, it's a removable discontinuity. If it goes like this, or they could both be open circles or whatever, see how there's a gap between them? This is a non-removable discontinuity. Okay? So when they talk about discontinuities and removable and non-removable and all that, that's what it means. Okay. Can the top factor? Yes. The top can factor into x squared times x plus 1. Can the bottom factor? So it's just x plus 1, right? Now, can we cancel anything? X plus 1s. So this function should be graphed just like x squared. X squared looks like that, right? So it should look just like that, except for we have to account for the fact that if we put a negative 1 in there, what happens? We're dividing by 0, and you can't divide by 0. So that is called a removable discontinuity. So what happens is, and yes, I know there's a graph right down below here. What happens is at negative 1, there's a hole. And it looks like that. So the answer is A. Is there a point of discontinuity at 0? What makes something discontinuous is if you're trying to divide by 0. Do we divide by 0 at 0 here? No, we divide by 0 at negative 1. So the answer is no, it's not discontinuous at 0. It's discontinuous at negative 1. And since it's discontinuous at negative 1, what kind of discontinuity is that when it makes a hole, but it goes right up to the hole on each side? It is removable. Okay? So we're going to start out with problems like that, talking about discontinuity, removable, non-removable. Now, that should have been in last time's video. I should have talked a little bit about that. Okay? All right, this one. Okay? On this one, can we factor the top or the bottom? Neither one. Okay? So I can't factor it at all. So I know that if I look at my denominator, if I set it equals 0, x equals negative 2. And so at negative 2, we have a discontinuity. Now, if I were you and I was a lazy junior or senior, I would get out my graphing calculator and just graph this right now. Okay, so let me be lazy. I'm going to turn down my screen a little bit. So I'll go y equals, and go 2 over parentheses. The parentheses are huge. You guys know how to make fractions on there from Wheels and Algebra 2? You push alpha and then what? Alpha y equals makes fractions? I thought it was alpha something else. Okay. Yeah, see, mine is an older version of the calculator, so mine doesn't do that. So, what? Yeah, how do you do it? Yeah. But again, mine's an older calculator, so it won't do that. But I can go 2 over x plus 2. If I graph it, it's going to look like that. Now, this line right here isn't really here. There is no line there. It's like a fake asymptote thing. Okay? So which graph is it? Well, it's obviously graph C. Okay? So what's happening? Well, at -2, it's going down, and then it's going up. Going down to negative infinity, up to infinity. Is that discontinuity removable or non-removable? Non-removable. There's not just a hole, it just totally separates. So is there a discontinuity at 0? No, because if I trace to 0, I actually get a number. When you get a number, it's not discontinuous there. Is there a point in discontinuity at 0? No. At 2, is it removable or non-removable? It is non-removable. Okay? Okay. All right. Let's graph this function. Okay? The absolute value of x plus 2 minus 1. The absolute value of x plus 2 minus 1. So if we go y equals, clear it out. How do you put in absolute value symbols? Math. Go to number, hit absolute value. Now again, mine's older. Mine doesn't put in absolute value symbols. X plus 2. Absolute value of x plus 2 minus 1. If we graph it, it looks like that. So what has happened? Well, I know the absolute value of x is a V shape which lands right on 0, 0. So what happens on the inside affects the x, so it moves it 2 to the left. What happens on the outside of the absolute values affects the y. It is 1 down. Okay? When it happens on the inside, it's the opposite of what you think. When you see plus 2, you think you go to the right 2, you actually go to the left 2. What happens on the outside is exactly what you think. You see a minus 1, it goes down 1. Okay? All right. So it should go like this and like this. So, identify the interval where the function is increasing. Well, it turns around at -2, so it goes from -2 to infinity that it's increasing. Now, here's where I sometimes have a question with how they do things. Yep, it is a bracket. It is a bracket, not a parenthesis. Interval notation. Did you do that in Algebra 2? Okay. So interval notation. If it equals something, it's a bracket. If it's like an open circle for greater than, less than, it's a parenthesis. Infinity always, 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 always has parentheses. Always. Because it's not a specific point. Infinity is not a specific point. So it's always a parenthesis. So it's increasing from -2 to infinity. Where is it decreasing? Well, it's decreasing this way from -2, right? It goes down as you go from left to right. So it goes from -infinity up to 2. Identify where it's constant. Well, it's not constant. Okay, it's not constant. There's not a flat line anywhere. Okay, so that increasing, decreasing, constant. If we look at this one, again, if you have a graphing calculator, let's use it. 2x raised to the third power minus x raised to the second power minus 2x. Now again, your calculators are much better than this, but here we go. All right, what do we got going on here? Well, we got a curve going on here. It's a cubic function, and cubics look like this. This is y equals x cubed. Now, when you have the 2 in front, it stretches it, and then this thing's affected this way and bigger hump and so on. So what I tell people to do is to trace it. Then you can kind of see what's going on. It still does go through 0, 0. But we got a hump there. How can I find where the top of my hump is? Well, I got a graphing calculator. The top of a hump is called a maximum. So I'm going to do maximum. I'm going to go second trace. And I want to do maximum, so I go to number 4. Enter. And I'm going to go to the left of my max, just barely to the left of my max, not too far. Press enter. And then go just barely to the right of my max. Press enter and press enter again. It'll tell you where the maximum is. Now the maximum is at negative, the max is at negative 0.434, and the y value of it is 0.516. Let's find out where the minimum is. So 0.43, negative 0.434, 0.516. So it barely goes like that. And then it goes down again. It goes like this. So let's find out where this minimum point is. So again, it's second trace, and then I go minimum, number 3. I go to the left of the minimum point, press enter. Go to the right of the minimum point, press enter, and press enter again. And it's going to be 0.768 and negative 1.220. Okay, so it wants to know, where is the function increasing? Well, it's going up all the way until it hits this max point. Then it's going down there. Then it's going up again after that. So there's 2 places it's going up. It's going up from negative infinity till it hits a max point. Well, which one is that? Well, that's this one. And it's going up when it hits this minimum point, and after that to infinity. Where is that at? Well, it's 0.768. So it's 0.768 to infinity. So those are how you get the 2 answers. Use your graphing calculator. I don't know how you do this without a graphing calculator, personally. Now, where is it decreasing? Well, it's decreasing in between these 2. So from negative 434 to 0.768. Where is it constant? It's not constant. There's not a flat spot. If it's horizontal flat, then it's constant. If it's never horizontal flat, then it's not constant. Okay. Find the minimums and maximums. Okay. Use a graph to find all local mins and maxes and where they occur. You just graph this and do the same thing. So y equals, clear it out, negative 3 minus x plus x squared equals graph. Okay, what type of a shape do we call that? Parabola. I want to find the what value? What value do I need to find out here to figure out increasing, decreasing? It's called the minimum. That minimum point is called something special on a parabola. It starts with a V. Vertex. I want to find the vertex of the parabola. Okay? So second, trace. There's not a vertex, but there is a minimum, so I go 3. I go left of the minimum, press enter. Go to the right of the minimum, press enter, and press enter again. What do you think negative 4.999955 is really saying? It's at negative 0.5, okay, and 3.25. If you put negative 0.5 in, it would be negative 3.25, okay? So the function has a local maximum at what? Well, what's the local maximum of a parabola here that goes up? There isn't one. There's no local maximum because it goes up to infinity in both directions. Does it have a local minimum? Yep. When y is negative 3.25 and when x is negative 0.5. All right. Boundedness. Boundedness. All right. So if we look at this, y equals 2 to the x power. So I'm going to graph it. 2 raised to the x power graph. What does it look like? Okay. It's a graph that has an x asymptote, and then it goes up like this. It's unbounded going up. It goes up forever. It goes to the left forever. Does it go down forever? No. No. So it is unbounded going up, so it is only bounded below. It is only bounded below. Number 7. Clear. Second square root of 7 minus x squared. Close the parentheses. Graph. It looks like this. It looks like this. Does it go up forever? Does it go down forever? So the function is bounded because it doesn't go up forever, it doesn't go down forever, so the function is bounded. I'm checking my answers because I don't use bounded very much. And then 4 to the x is the same as 2 to the x. It would be like that, so it's bounded below. It's only bounded below because it's unbounded going up. Okay? All right, so your assignment's out there. Get to work on your first one. We will do a second one a little later in class. Yes. Riley has to come to the office? Okay. Riley, bye.